In this demo, we're going to learn how to compile and run the Coriolis example without any further complication. I'm going to get a console here. This is when you log in on the cluster. This is Xea's machine. The first thing I'm going to do is I'm going to log in on the cluster master node, which is where we're going to run the model. Remember that when you first log in, you're not on the cluster, so you have to log in on it. So now I'm logged in on master. I type L to see the directory structure. So to compile the code, all you do is you go cd roms-src, which is the source directory. You do an ls. You go in the directory applications. You type an ls, and you run the script compile coriolis_compile. You wait for this script to compile. This script, the nice thing is going to do everything for you for now. Later in another tutorial we'll learn in more depth what exactly the script does to compile, and we'll also learn more about the code. But this is just to compile the code. Once you compile the code, we're going to go back to our home directory, cd. I'm going to type L to see the listing of the directory, and at this point we're going to go in the roms-example directory, type ls, and you already have their directory Coriolis where you can run your example. You type ls. To run the example, you have to use a particular command called qsub, which is a command that submits a job for the cluster, so that then it will be processed and executed for you. And when you use qsub, you also have to indicate where the information of the job is, and for this particular Coriolis example, the information is contained in run_model.pbs. So we put this into the queuing system, we type return, and at this point the execution of the model run has been submitted to the cluster. So it's running in multiprocessors, in this particular case 4, as we will see later. And if you want to see if the job is running, you type the command qstat, and this gives you information about the jobs that you have submitted to the cluster. In this case only one. This is the ID of the job, a name, your user, and then here under the letter S you find the letter R, which stands for running. So this job is running. The output of the job is going to, if I type L to see the directory structure, the output of the job of the model is going to be in the directory out. So if you go in out, you type ls, and you find the netcdf files that contain the output of the model. In particular, the file his.nc, which is a netcdf file, and you can list the type of variables that are contained in this file by using the command ncdump -h his.nc. You type return, and as you can see, this is a listing of all the types of variables. If we go scroll a little bit up, we find that there's a variable called zeta. The long name for zeta is the free surface. The units are in meter. The time variable of this variable is ocean time. The coordinates, and here it tells you the full name. It's a free surface of the model, and so forth. And then you have u-bar, for example, which is the vertically integrated u-momentum component, which is the velocity in the x component, the units, meters per second, and so forth, and all the variables that are in the output file are follow with this similar descriptions. Okay, so I type L, and at this point all you need to do is to wait for the model to complete its run, and you will know when the model is done running, because if you type qstat, there's not going to be anything listed anymore. In fact, this execution should only take about 2 minutes or less, and when the execution is done, you will also find some additional files in the directory where we submitted the run script, and these files are these pbs.*, these two files here, and these contains basically just some log of the model of the queuing system, of the fact of the job that you submitted. So and typically if something goes wrong, you will find that pbs.error has some information. In this case it's empty because nothing went wrong. There's also another file, the log file, which is the model log file. You can type more of log, and here you have just the output log of the actual ROMs code as it's running, and see you have all parameters, and this is now showing you that it's running the time steps as you go further down. Okay, so this is all for the simple execution. So once again, there are really two steps. The first is the ROM's src. You go in the application directory. You compile the model by typing coriolis. Okay, you do that, and after you compile the model, you go back to your home directory in ROM's examples ls coriolis ls, and then you just submit the job by typing q sub run model pbs. You submit this job. qstat shows that the job is running. When the job, if you want to stop the job, for example, you can type qdel, and then you just give the ID of the code, and this will actually stop the job and kill it in case you want to do it. But anyway, when the job is finished, you go in the out directory and you will find your history files in your output.